A common problem that deals with derivatives and antiderivatives is one called a differential equation. So if I have an equation that has a derivative and a function in it, so dy dx equals some function, or y prime equals some function, these are known as differential equations. And by no means are they the only differential equations. In fact, these are probably some of the easiest differential equations which exist. However, for the purposes of what we're trying to do, this is a nice introduction to the idea of a differential equation. And the goal for this is to find what y is. We know what the derivative of y with respect to x is. We know what y prime is, but we're trying to solve for what y itself is. And in this particular case, the solution is just y equals the antiderivative big F of x plus c. That's it. That's all we're trying to do right now. So if I have dy dx equals 2 times x to the 5/7. So what I've really set up is I've said, I know that the derivative is this. What's the original function if the derivative is this? Okay, well, to do that, we need to find the antiderivative. So we use the power rule for polynomial equations. We add 1 to the power. So you could say, or you could say y or y of x. Y of x is a different notation. Often this just says y equals something, but you may see, depending on what you read or where you look, you may see y of x. And that's only to emphasize that y is a function of x. We add 1 to the power. And then we divide by that new power. So 5/7 plus 1 is 12/7 plus c. And we're given 7x to the 12/7 over 6 plus c. And that's the solution to that particular problem. Now for this one, we would do the same idea, but we have dy dt. So in this particular case, you could say that y equals, or you could say y of t equals 63 t to the 7th over 7 plus c, which is 9 t to the 7th plus c. So those are your general solutions to the differential equation. While we're at it, let's go ahead and add one more, just so that we know it. We could say dy dx equals cosine of 1/2 x. Now, a good starting point is to think, okay, well, if I end with cosine, I know I have to start with some sort of sign. I don't know what, but I have to start with some sort of sign. So let's assume that our answer is sine of 1/2 x plus c. Let's assume that's the answer. Now let's take the derivative of sine of 1/2 x. Well, then it would be cosine of 1/2 x. By the chain rule, we'd have to multiply by the derivative of the inside. So it would be cosine of 1/2 x times 1/2. But we don't have a 1/2 here. So we have to figure out something that would cancel that 1/2, which in this case is a 2. So to solve this, that's how you get it. You set it up and then take that derivative of what you get and then kind of twiddle around until you get it, because it's going to take some time to figure out how to do this. But once you do, it's pretty straightforward.